Of course, now we have two linear regressions because my echo capture conked out in the middle of me talking, so I apologize for that. Okay, so we were here at the model summary. So we'd explained that when we put all the variables in, this basically told us that all the variables together were significant. And then it's going to remove or back out the ones that aren't significant. So the first one it took out was symptom duration. The R-squared basically didn't change, and you can see the F value didn't significantly change. The second one was age that it backed out, and basically the R-squared went down a little, but it's still 25%, so not meaningful. And then you can see that was not a significant change. So down here it says for model 1 everything was included, and model 3, which is the last one that we're going to interpret, that we had comorbidities and their initial score and their pain scores were the best predictors of their change score at visit 5. Okay, so now it runs an analysis of variance for each model. So if you notice, as you go from model 1 to model 2, the degrees of freedom changes. This is because one less variable is included. And then in this case, it stepped down another level. All of these still stay significant. So we know that the model, in combination of comorbidity totals, initial score, and pain as a group, help predict change scores at visit 5. So now when you go down here to the coefficients, we're going to look at model 3. That's the one we're trying to indicate. And then we have the information about the parameters. Sorry. My bad. This is indicating the coefficients and the collinearity all staying below 3, which is good. These are the variables excluded. And where are my individual parameter estimates? Well, okay. I must have not clicked on something. I apologize. Estimates. I didn't click on something. Human error. Wonderful. We're going to run the exact same analysis, and I'm going to jump down to the thing that I haven't explained. All of this will be identical. There we go. There's our coefficients. So now, here in model 3, we have pain, initial score, and comorbidity total. Again, variable inflation factor all is well below 3, so we don't have any multicollinearity. We have the confidence intervals. We have the coefficient standard errors, which generates the confidence intervals. But basically, this is now a model that is explaining the change score at the first 5 visits. So we're going to use these betas as the components, or in this case 3 factors, to interpret our best prediction of visit 5 outcome, or visit 5 change score. So let me copy that. Let me go over here to my Excel, add a clean sheet, paste. Okay, so now I have all of that information in my Excel file, and I'm going to interpret this. And so basically, the line of best fit is a linear regression, and we're basically going to create a line. So if you remember back a long time ago, you learned that a line was y equals mx plus b, and in this case, the b, or the error, or the constant, is given to you here, and then all the mx's, which we have 3 of, are these calculations of these beta coefficients. So y in this case is our change score at visit 5. And I'll just make this a little bigger, sort of try to keep it all in the same cell, is going to equal our constant, which is 5.937. That's our constant. Okay. And then for each individual person, they're going to have their variable, which would estimate their final score. Okay. So now we're going to have pain. The pain factor is -1, -1.706, and then you're going to actually multiply that. That'll be the individual person's score. So we'll put a variable in here in a second. So this is the individual pain. This would be plus, so we'd sum that up. So it's just gonna keep doing that for me. Plus, so the next one is going to be the initial score. This is the parameter of the initial score, is 0.449. And this is going to be the individual initial score. So some value x will go in here for an individual person. Sorry, can't spell. Plus our final, which is going to be the comorbidity total. So that parameter is going to be minus 2.995. We'll have another value of x, and this will be the individual's comorbidity. Okay, so based on these factors, I can put this into an equation. Sorry, this should have a plus also right here. So I'm going to move this down 1. All right, so mathematically, if I'm trying to estimate change score, I'm going to need this value plus one person's individual pain score, right? So let's say they came in with a pain of 5. Their initial score, if I look back at the descriptives on my data set, let's see what the typical pain score is. Oh, that's pretty close, 5.7. Their initial score is about a 40, and their symptom duration is 7 months. All right, so we'll just use those as our predictor in our predictor equation. Okay, so this was a 40, and oh, I looked at the wrong variable. Comorbidities is what I need. Was 1. Gotcha. Not symptom duration. Yep, back to Excel. Oop, wrong Excel spreadsheet. There we go. And that was 1. So that's basically going to be minus that. Okay, So to predict this, I'm basically going to take these values and multiply them. So this is going to equal this times this equal this times this equal this times 1. Okay, and this is a 5.937. So, assuming these are sort of standard values, my equation would be adding all of these up would give me my change score at visit 5. So it's equal this value plus this value plus a -8. So that lowers their change score the more pain that they have. Higher initial score, more likely to have more change, a positive value, and comorbidity. So based on those typical values, I can tell that patient that they are likely to have a 12-point change. And so interesting enough, on a quick dash, a 12-point to a 14-point change is a meaningful improvement on that score. So this basically is indicating that the lower the pain, more likely to do have a bigger change, but pain is a negative, so it brings it down. Higher initial score, more likely to change, makes sense, more room to improve. And then more comorbidities, not likely to change as much. So a reasonably logical prediction. So if we write an interpretation of this, is we have a so there was a significant predictor model for pain, initial score, and comorbidity total that predicted change score at visit 5. So my p-value here, right, was quite significant. If we go back to our SPSS output, if I look at the third predictor model summary, not for the change, but all of this is at 0.000. So that's with those three predictors. So I would write that and say that it was, oops, keep picking the wrong Excel spreadsheet. Less than 0.001. And I would probably end my sentence there. These factors explained 25% of the variance associated with quick dash visit 5 scores. And so my variable there would be my r squared, I'd superscript that, equal to, going back to my output, 0.251. Dadgummit, sorry. So that's my results section interpretation of my model. So hopefully that was helpful to allow you to understand how to perform and interpret a regression model. For your homework, you're going to use predicting the change score at the end. And I don't think I had the word at discharge in the instructions. I think I added that today. So now you're going to use a different variable, not the visit 5, but the discharge score. You're going to use some of the same variables, and I added a couple of added the resistive exercises for the final change score. So it's still the age of the patient, duration of symptoms, pain level, number of comorbidities, change score at visit 5, resistive exercises for the shoulder, use all of them, and then use the default enter and remove variable. So in the Excel spreadsheet, what I want you to include is the in the regression tab, you're going to have the descriptive data, the correlations, the variables entered and removed, the model summary, the ANOVA, the coefficients, and the collinear diagnostics, and then write out your finer equation and interpret it. So it should look something like what I have here. I don't care about the color. So that was just the log. I just copied the log over. Descriptive statistics. This is for what we just did. The correlations. The variables entered and removed. The model summary. The ANOVA. The collinearity diagnostics. The coefficients, which have the collinear variable inflation factors, and the collinearity diagnostics. And then I just showed you what I wanted in the interpretation. Hopefully that's helpful, and I'll be happy to answer any questions in class on Thursday.